This is the solution to episode 2, the two ropes problem. The tricky thing about these ropes is that you don't know anything about how they're going to behave if you light them somewhere in the middle. Any location you light that's not an end is going to give you two burning pieces with random burn times that happen to add up to 60 minutes. So the only starting points you can make clear predictions about are those ends of the ropes. Each rope has an hour of burn time, and it doesn't matter which end you light, it'll take 60 minutes to go through. We need to measure 15 minutes though, so how can we speed things up? Well, one thing we can try is burning one rope from both ends. Now the rope is being consumed twice as fast, so no matter where the flames are going to meet, they'll go out after they burn for 30 minutes. So now we can measure 30 minutes from a 60-minute rope, but again we need 15 minutes. We could use the same approach to measure 15 minutes if we had a 30-minute rope. And we can make a 30-minute rope by burning away half of our second 60-minute rope. So the solution is to light both ends of one rope and one end of the second, all at the same time. That way when the first rope goes out, you know it's been half an hour, so the second rope has burned half of its material off, and you can now press the button and light the other end of this burning rope. We now have a 30-minute rope with both ends lit, and that means it'll go out in 15 minutes. Once it does go out, you can press that button again, and the door will open. This solution works because two flames burn through a rope twice as fast as one flame. This might seem obvious, but it only works because the flames are independent and identical. They don't affect each other's burning, and the rope burns the same way no matter which flame is burning it. The same thing works for driving, for example. If you live 2 hours from a friend and you drive towards each other, you should meet after an hour of travel, regardless of how the highways and back roads may be distributed across this trip. It's also interesting to think about where this reasoning doesn't apply. For example, when people are working together on a project. People are not independent or identical, and so two people won't work twice as quickly as one. In fact, at some point, if you add more people to a project, you could actually make the project take longer. This is known as Brooks's Law, coined by Fred Brooks in his 1975 book on software engineering called The Mythical Man Month. Assuming that people burn through projects in the same way that flames burn through rope has no doubt cost many a manager some real losses. You can start to see why things are a lot easier to calculate when processes are independent and identical, and these assumptions are very important to confirm when approaching many types of problems, imaginary or otherwise. Thanks for watching, and be sure to check out this week's new problem, the line of 100 hats.